Well, this is Unit 3, Lesson 2, and we're going to be going over information about relations and functions today. So a graph with separate points. So these points like this looks like a scatter plot. Also could look like that. These are called discrete or discontinuous graphs. Now, continuous graphs, that's when you have those straight lines, you have curves. Regardless, they're going from one side of the map to the other side. And they're continuous. Now, any set of points is a relation. A relation is any set of points. Now, the domain is all of the x values. The range is all of the y values. Now, how do I write a relation? Well, there's 4 ways to represent a relation. You can write the same relation in 4 different ways. So, if you're given a set, then you label your coordinates. Label the ordered pairs. Label the x's. Label the y's. It makes it easier when it comes to creating a table to write these down. So I have all my x values on the left, -3, -2, 1, 3, and -3. Then I have all my y values on the right, 1, 0, 2, -4, and 5. Now, if I wanted to graph these points, I go left 3, up 1. So left 3, up 1. Here's point A. Then left 2, nowhere. I don't go up or down. Then right 1, up 2. Is that correct? Right 1, up 2. Right 1, up 2. And I'm creating a scatter plot. Right 3, up, nope, down 4. And then left 3, up 5. And there's my graph. Now when you're mapping these things, you have your domain, you have your range, or your x's and your y's. So I'm writing the numbers. I have 3, -3, -2, 1, and 3. I don't include the last 3, and I'll show you why in a second. And we have our y values. We have 1, 0, 2, -4, and 5. So essentially 3 maps over to 1, -2 maps over to 0, 1 maps over to 2, 3 maps over to -4, and -3 maps over to 5. That's how we take care of a repeating x value. Now when you want to do your domain, you can use that information from the map. X equals -3, -2, 1, and 3, close bracket. And my range, my y values, y bar, y equals 1, 0, 2, -4, and 5, close curly bracket. Now, have a new set. Here's my example. Label your x's and y's. So for my table of values, I have -2, 0, and 3. Then 4, 0, and 3. All right. I'm going to take that same information, put it in a graph. So let's find the next page. So I go left 2, up 4, 0, 0, and 3, 3. And then I have -2, 0, 3. And 4, 0, 3. So my domain, x bar, x equals -2, 0, 3. Y bar, y equals 4, 0, and 3. Close the curly bracket. Now, the next part we're going to do is just talk about what a function is. So a relation where every x value matches to exactly 1 y value. So that's what a function is. A function is one where every x value matches to exactly 1 y value. Okay. So no repeating x values. When you have order pairs, if the x value repeats, then it's not a function. Not a function. When you have a graph, you use the vertical line test to determine whether there's a function. So if a vertical line intersects the graph at more than one point, it is not a function. So we're gonna just looking for those repeating x values. So here's an x, here's an x, here's an x, here's an x, and none of those repeats. So this is a function. On the next portion, this is a function. No x values repeat. Here's an x, here's an x, here's an x, here's an x. This is not a function. Not a function because 1 repeats. Looking at the next one, I have -2, -1, 1, and 3. This is a function. No x values repeat. So the next portion, you're going to go ahead and do this portion on your own. Okay? And you're going to check the notes that I have there in order to complete that portion. You should be able to do it. Go back and look at the video. This is a good opportunity to do some in-class work. So we're going to move on. So how do I find the domain and range of continuous objects? So when you have continuous graphs for set notation, your domain and range will be used, written using inequality symbols. So less than equal to, greater than equal to. For domain, we scan from left to right along the x-axis. And for range, we scan from the bottom to the top, okay, along the y-axis. So for the first one, our domain is x equals all real numbers. The range starts at, looks like -2.1, -2.1, and it's less than or equal to all the other y values going up. Is this a function? Yes. Next one, domain, x belongs to all real numbers. The range starts at -5, goes all the way up to positive infinity. Is it a function? Yes. Next one, domain starts at -3, goes towards the right to positive infinity. -3 to positive infinity. The range is is x equals. Sorry, we're supposed to be using set notation here. So 5 less than or equal to y less than 8. Less than infinity. 5 less than y. 5 less than y. My bad. 5 less than y. Okay? And it's a function. My domain over here, we're going to have -3 less than all your x values. So x bar, -3 less than all your x values. Close all those curly brackets. Range, we're going to have y belongs to all real numbers. Nope, this is not a function when y belongs to all real numbers. In that sense for a parabola. Next one, x belongs to all reals. Y belongs to all reals is a straight line. Yes, it's a function. Next one, we start at -4, go over to positive infinity, and we have -4 is less than x. Y values, we have 1. 1 is less than all the other y values. 1 is less than all the other y values. Yes, this is a function. Last one, starts at -2, goes over to positive infinity. So we got -2 is less than x. And all my y values are less than 5. And yes, this is a function. Okay, that went rather quickly. I suggest that you go back and do some of the set practice from lesson 1 in order to be an expert at that particular type of problem. So one of the things we need to do for this unit is function notation. So basically, this allows us to solve to get the range for a number of values. So function notation is just a precise way of giving information about the function without a rather lengthy written explanation. And the most popular function notation is f of x, which is read f of x. So the example I've given here is f of x equals 3x plus 5. Y equals 3x plus 5. These are the same types of this is the same way we can use those two, f of x and y, interchangeably. Or a of s equals x squared. So that's an area equation formula, but we won't really be using that just yet today. So when we're evaluating a function, it wants us to find the range or the y values. What I like to do is I like to rewrite this information. So I'm looking for y values, and I like to number my x's. My first x value, my second x value, and my third and fourth. And what I do is I go to the function, and I say f of x of 1 equals. I'm going to replace the x values. So the first x value is -2. So -2 squared plus 3 times -2 minus 8. What I get is 4 minus 6 minus 8 equals -10. There's my first y value. F of x sub 2 equals, well, 0 squared plus 3 times 0 minus 8, which equals -8. There's my second y value. Then I'm going to come over here, f of x sub 3 equals 3 squared plus 3 times 3 minus 8 equals 9 plus 9 minus 8 equals 10. Last one, f of x of 4 equals 6 squared plus 3 times 6 minus 8 equals 36 plus 18 minus 8 equals 46. Now when you write your range, you're going to write curly bracket y bar, y equals -10, -8, 10, and 46 for these particular x values. Similarly, with when we're given a range and we're asked to find a domain, we're going to say y equals 2x minus 9. So here's y1, here's y2, here's y3. So what I like to do is set up three different equations. -7 equals 2x minus 9. We have 5 equals 2x minus 9. 11 equals 2x minus 9. So I'm going to add 9 to both sides. And I'm going to get 2 equals 2x's. And then divide both sides by 2. First x value equals 1. Then I'm going to add 9 to both sides for the second equation. You get 14 equals 2x's. Divide both sides by 2. For a second x value equals 7. And then add 9 to both sides. 2x's comes down equals 18. Divide both sides by 2. No, I'm sorry, 20. 20 equals 20. And x equals 10. So when I do my x values of my domain, I have curly bracket x bar, x equals 1, 7, and 10. Close the curly bracket. And that was all she wrote. Now, function notation with graphs. So function notation with graphs. So if you are working on the inside, this is an x value. Anything on the outside is a y value. So when we're given function notation, basically f of x, the number on the inside, when there's a number on the inside, that's an x value. And so what I like to do when I have f of 2, I'm talking about x equals 2, so I'm looking for y at that point. And y is the whole thing. Y is the whole thing. So here, I'm looking for x equals 2 and x equals negative 3. So I'm just going to come over here to 2. Here, x equals 2, and this number is 1, 2, 3, 4, 5. Negative 5. And then, when x equals negative 3, 1, 2, 3, that number is 0. What about y values? Well, f of x equals 5. This is a y value. So y equals 5. This is a y value. So y equals negative 3. So I'm going to go to where y equals 5. 1, 2, 3, 4, 5. And come over here. I got 1, 2, 3, 4, 5, 6. X equals 6 at that point. And then at negative 3, and where y equals negative 3, I have 3 different points. I have 0. X is 0. X is negative 4. And x is in between 3.5. So negative 4, 0, and 3.5. Is this a function? Yes, there are no repeating x values. For the next portion, I do want to do like number 1. So number 1, you're replacing x with m. M equals x. So I'm going to have 1 minus 3m's. Number 2, this is g of x. We want to know what g of 4 is, or when x equals 4, what's the y value? Come over here, it's 0. When you're given a set, we want to find h of 5, or when x equals 5. If I go, when x equals 5, I get negative 3. So I'm going to let you work on the rest of this for practice. Touch base with me if you're still stuck. I think if you go back and play the video, if you take the time to do those things, you'll find that it's not as hard as you think it is. Please, 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 please use videos, use Khan Academy. Have a good day, guys.